done this before, but okay. So
We
I
believe in
started
you.
out. I wanted to talk about Null Island. I want you guys to kind of get in the mindset thinking about latitude and longitudes, um, because longitudes are they're kind of a dynamic in terms of distances. And I know a lot of you guys are GIS people, so I'm sure you guys know a lot about this. But as these slides, I kind of want to show that as you get further away from the equator, uh, and can you see like that this one's Chicago? Um, do you see that slide or
Yep.
okay, awesome. I want to show as we get away from the equator towards the poles, a degree of longitude, the distance gets a lot thinner. And here's even up at Svalbard, Norway, and a degree of longitude is only about 14 miles wide. Um, whereas in Chicago, it was 52 miles wide, and um, over by Null Island, which, as you guys probably know a lot about that, but Null Island is where the prime meridian or the Greenwich meridian intersects the equator. And a degree of longitude and a degree of latitude is almost square. It's still rectangular, but it's about 69 miles by 69 miles, or 111 kilometers by 111 kilometers. So I want to talk a lot about the xkcd comic. And so we're going to start out, and I drew a rectangle, 1 degree by 1 degree. And this is the first entry in the comic. And he says you're probably doing something space related, which is kind of a foreshadowing, as you'll see. And I decided to add a photo there from the Hubble Ultra Deep Field, and that's one of my favorite photos. And if we get some time later, we can talk a little bit about that. But yeah, take a look at that rectangle, and you can see a degree by a degree. It's quite. It's it shows quite a big area. So we move in and to the next line, and we go to a tenth of a degree. And so that big rectangle is the rectangle we were just looking at, showing Florida. And the small rectangle is a tenth of a degree by a tenth of a degree, longitude by latitude. And it's about 6 miles wide. And if we keep on moving in, as you can see, we're starting to get closer to Earth, and you're starting to see buildings and structures and roads. Um, and we're going to keep on moving in, kind of like flying through windows. And now we're at down to 100th of a degree by 100th of a degree. And so about a kilometer wide. And if we keep on moving in, um, this is 1,000th of a degree. And this is, you're probably pointing out specific suburban cul-de-sac. And you can kind of get a feel for what that looks like. I put that grid on there to kind of give you an idea of what it's like a graticule. And each of those is 100th of or 1,000th of a degree wide. And moving on, here's this, and the slide kind of evolves, but here's a comparison of WGS84 and NAD27. And most, I kind of missed the slide earlier, but when we're talking about coordinates, degrees, minutes, seconds, in the modern context, you're almost always dealing with WGS84. It's pretty much the standard when you're on your Garmin or looking in Google Maps. When you see the degrees, minutes, seconds, it's probably WGS84. But that's not always been the case. Previously, before GPS technology, uh, at least in North America, we based it on a North American datum from 1927. And this is kind of a mesh of different triangulation networks that were developed in the 1920s. They united Canada and Mexico. And this was all done by triangulation. It was obviously before satellites. But the difference between NAD27 and WGS84 is NAD27 is actually the base. The origin of that survey is actually in Kansas, because Kansas is in the middle of the United States, and they kind of built the triangulation network out from there. WGS84 is based as Earth centered, or really the center of the Earth is the origin of all the coordinates. And there's other factors and variables that are involved in the differences, such as the flattening of the Earth and the radius. Over time, the radius of the Earth has changed. There's been many different values. Different countries historically have had different radiuses or radii of the Earth, and this has caused problems in trying to unite triangulation networks across different countries. But the point of this slide is to show you that there's really going to be a datum shift between WGS84 and NAD27. And if you don't know where your data is coming from, you're kind of in trouble. And as you can see here, this shift was about 125 feet. Um, and it's kind of a dynamic shift. There's really no like easy formula to convert WGS84 to NAD27. Fortunately, the NGS, uh, they provide a website where you can do this easily, and you can import and export many points simultaneously, and that's provided by the National Geodetic Survey. Um, so, um, does anybody? I'm kind of going fast here. Does anybody have any questions? Nope. All right. So next slide, and there's kind of a lot going on here. Uh, let's see. I might as well just move this. Um, so you can see. I'll come back to that, but this is the xkcd comic starts to focus in on the visitor center at the Kennedy Space Center. And here's a nice illustration of the rocket garden at the Kennedy Space Center. And you can see the bunch of cool rockets. There's the Saturn rocket that was used in the Apollo space program that got man to the moon. There's the Gemini Titan. That was originally an ICBM, but it fortunately was never used for that. It was used for payload and cargo delivery to space. And there's a couple other cool rockets, and if you guys want to look it up, there's a lot you can read about. But Randall actually chose to focus this comic on the Delta rocket, and I'm not really sure why he chose the Delta rocket. Um, the Delta rocket's like a long running rocket program that's used to deliver cargo to space. And I tweeted at him and asked him why he chose the Delta rocket. He never got back to me, but I'm still pretty curious. I think it might just be that it's in the very center of the rocket garden, but it could also be his work with NASA or something along those lines. So this is the illustration. I'm just going to move this out of the way. So we can see here. Can you see my mouse? Might as well use it.
Yes.
Okay, cool.
Yep.
So in the previous slide, I showed you the WGS84 versus NAD27. This is the WGS84 rectangle. And if we move into the next table, row in the table, we get to this entry, which is you're pointing to a specific person in a room, but since you didn't include the datum, we can't tell who. And kind of like I mentioned earlier, it's critical that you know the datum information. It's kind of safe to say a lot of general GPS work is probably WGS84. But still, we're all kind of GIS people. We know how important it is to have good metadata. So this row right here points to the very top of the rocket, and it's about 12 square feet. And obviously, I can't zoom in anymore on Google Earth. It'll just be a blurry pixels. But so in this talk, I wanted to talk about coordinate precision, and obviously the kind of the main point of this of Randall's comic is there comes a point where too much coordinate precision is actually useless, and when you get down to probably past that Waldo on a page, it gets when you're pointing out a specific grain of sand, it's really not that useful, and if you give someone information, the data that has that much precision, it kind of shows that you really don't know what you're doing with your data. Um, because any GPS program or hardware like a receiver, I use GPS at work, RTK receivers, and it'll give you just digits like the length of pi, if you want that. But that kind of implies an accuracy that's not there. And really, kind of the point of this comic and the point of this talk is to kind of think about correlating our accuracy and our precision. Um, and so, uh, so let's move on. I originally gave this talk to OpenStreetMap, so I have some OpenStreetMap slides. Um, and here's I had kind of a trivia thing here, and you can see that we have 2 points with Latin longs, and the trivia was kind of to ask, what is the distance between these 2 points? Um, because it's actually not that easy. You think you have the data, uh, but it's really quite difficult. And this, as a surveyor, I almost never use Latin long. It's just not useful. Um, it's not really practical for the kind of work I do. So the first answer was the Haversine formula, and this works great on a sphere. If you look over here, this is the Haversine formula. It's a somewhat simple trigonometrical formula, and you just need to have a radius, and you need your deltas between your Latin longs, and you can get an answer pretty easily with the calculator. But the problem is it's on a sphere. Uh, there's no flattening, nothing like that. There's no geoid. So this is more or less a close answer, but it's not scientific. So the Haversine formula isn't really the right answer. It's really, the true answer is Vincenti's formulae, and that's actually a series of formulas that will inverse between two Latin longs. And you can see this is all of the calculations. And I'll be honest, it's way above my head. Um, this is kind of some PhD level math. um, but for a surveyor, for your general surveyor doing cadastral work or doing engineering work, they don't want to deal with any of that. Uh, so that's why surveyors use state plane coordinate system. You guys probably, some of you might know about state plane coordinate system. It's kind of outside the scope of this talk, but if you want to talk about it later, we can talk about it. Um, but that's just a slide to talk a little bit about my work and why we don't use Latin long. Um, so next, here's a little slide about OpenStreetMap. Um, I'm a big fan of OpenStreetMap. I love how things are turning out. And my question was kind of, what is the coordinate precision in OpenStreetMap? And you can kind of see this is from the wiki, and the coordinates in OpenStreetMap go to 7 decimal places, and it's kind of a it kind of has to do with the data types in computer science. If you have certain if you have a float, which is a decimal place, uh, the numbers if you go too many decimal places, in essence the math kind of breaks down. I'm not really a computer scientist, but um, it's better to have only to go so many decimal places. Um, and that's 7 decimal places. So that's your pointing Waldo on a page. Uh, I think for OpenStreetMap work, that's good enough. That's like survey grade, and I don't think any of OpenStreetMap is really survey grade. So I'm gonna take a second here and drink some water. But does anybody have any questions? I'm not going too fast.
I was just going to ask real quick, Patrick. Did you say that you don't like to use the state plane coordinate system,
Oh no,
or
I
that
do like
you
to use
guys
this.
do?
We
Okay,
do.
okay.
Um, and it's kind of like state plane is very Cartesian. Uh, there are scale factors, but for small sites, you can just do it like a Cartesian, and like Cartesian, I mean like using graph paper. kind of like in high school, and you have your X and Y axis, and you can hypotenuse and Pythagorean theorem most of your work. So yeah, surveyors love state plane coordinate system.
Right. We use the same thing, and so I couldn't quite catch it if you said I don't use the state plane. I was like, oh, okay. Thank you.
So the next slide is to kind of do some more looking into OpenStreetMap. This is what the rocket garden looks like in OpenStreetMap. I kind of have a mask there, but it looks pretty nice. And we have that Delta rocket. And you can see the way OpenStreetMap works is there's nodes. And each node is just a point. And this rocket is 20 nodes, which makes it like a polyhedron. And this is kind of a fun slide. I really like looking under the hood and seeing all of this like XML and database type stuff. And so this is what, does anybody have a question? So this is what the data looks like. There's all these nodes, and let's see. So it was created by 3 Yoda. We have a unique ID, change set number, and here's the lat long here. So this is, if you look under the hood of OpenStreetMap, this is what the whole database looks like. And I think just like a few days ago, they hit 100 million change sets, or change set number 100 million. So that's pretty exciting. Are there any other like OpenStreetMap fans in this chat room? I'm just curious.
I mean, I like it.
Yeah, there's an OpenStreetMap Mappy Hour that they do once a month, and if you're into it, I recommend it. It's a lot of fun. They do a good job. It's I think if you just Google OpenStreetMap Mappy Hour, you can find it, and it's a Zoom meeting, so anybody can participate. It's in America, and it's usually about this time in the evening. So I don't know who, someone opening their car door.
It's Quint.
Oh, sorry, I didn't mute myself.
And this slide's talking about JASM. For those, if you're not really into OpenStreetMap, JASM is one of the editors. It's kind of like an AutoCAD. And if you want to do some editing in OpenStreetMap, it's probably one of the better programs. So this is what the rocket looks like in JASM. And you can really see the nodes here. And on this slide, like this is the maximum zoom on OpenStreetMap. So you can't really get the granularity. So I opened JASM and just to see what it looks like and looked at the data. I played it a little bit more with JASM. I wanted to see with JASM what's like the smallest polygon you can make, and JASM will actually go to about 10 or 11 places. But when you upload it to OpenStreetMap, they will round it to that 7 decimal places. And here's my polygon. You can see that the scale here, that's 3/100 of a foot, about 9 millimeters, and that's a dime scaled to that. And then I have a slide about Google Maps, the precision in Google Maps, and you can see that they go to 5 decimal places, and that's the person in a room. So, and like, look at Google Maps. OpenStreetMap has all the rockets and everything, and Google Maps is just kind of a bland green park kind of style. So, if you can't tell, I'm kind of I don't know. I think OpenStreetMap's. I hope OpenStreetMap can overtake Google. And I think a lot of you guys have read those articles by Justin O'Byrne and I think I can't remember the other guy, but I think Morrison. anyways, there's kind of a lot of like there's almost like kind of blood in the water right now between Google Maps, OpenStreetMap, and Apple Maps, and it's kind of exciting to see uh, seeing these big Apple and Google fight it out, and meanwhile the scrappy underdog OpenStreetMap is kind of taking it by storm. Um, so speaking of Apple Maps, here's the data in Apple Maps, and I will kind of move this slide out. And this is like a few weeks ago or about a few months ago. I got this from Apple Maps, and I feel like Apple Maps really has a long ways to come. I'm actually kind of disappointed. The visitor center is right here, and this is a screenshot, but you can't really tell that there's a visitor center. You can't even see the road, and this is a kind of a scaling thing too. But I don't know. It's kind of boring, really. Um, so here's kind of a zoomed in oblique view, and at least Apple Maps shows the paths and kind of the buildings outline. Um, and you can see here the coordinates uh, are actually 6 digits, and Randall went from 5 to 7, so he actually skipped the 6 digits. But it's somewhere between that person in a room and Waldo on a page. Um, and then I'm really curious about boundaries, about international boundaries, and I frequently like to post cool maps about boundaries on Twitter and Reddit. So it got me thinking about what do official government documents say when it comes to coordinates when they're kind of delineating their boundaries. So I did a really arbitrarily kind of spontaneous Google search, and it's nothing like official or anything like that, but just to see what different different governments have put out there. And as you can see, there's a lot going on in this slide, but so this is some legislation I found in Australia dealing with their continental shelf. And you can see that they have some coordinates here. And you can see like there's this cent symbol and the square symbol. And I think there was some sort of OCR transliteration problem. I posted this to the GIS Reddit, and some of you might have actually seen it. So it was for this slide. Because I was trying to figure out, hey, like, am I missing something? Like, is there something I don't know about coordinates? Because I've never seen that symbol or square symbol, but I think it's just should be a hash mark, like a minute and a second. And since this is DMS, I obviously converted to this number. And this actually was 64777. It was a repeating 7 because of the nature of DMS numbers. But I kind of lopped it off and just rounded to 8. And so this is like an Australian document, and it's kind of just a survey to see what's out there. So that puts us at 7 digits. And here's my Australian Waldo, or actually outside of America, he's called Wally. Only in America, he's called Waldo. So we'll say Wally. And then, oh, this one's a mess. So I'll pull some of this out of the way. And gosh, it's a mess. So I found some legislation in Great Britain, and this deals with the North Sea area. And the North Sea is it's rich in natural gas, and there's some oil, and it's kind of it's a contentious issue between UK and Norway. And so they need to define their boundaries as precise as possible. And here, if you guys can kind of see that, here's from this legislation. And once again, this is not, official, 100% official. This was kind of just me in an afternoon throwing some slides together. So so this might have been changed since I created this or since I found this. But here's they have degrees and then they have minutes, but they have decimal minutes. There's no seconds, which is kind of funny. Like you often see DMS or just decimal degrees, but this is the first time I've ever seen decimal minutes, or yeah, decimal minutes. So that puts us at these 5 digits. And this is, you're pointing to a specific person in a room. But it's kind of like, that really got me thinking. That's, for an international boundary, that's really not that precise. And there's William Rankin wrote this wonderful book about just kind of the evolution of technology and mapping. And I'll try to move this, pardon all this mess. Anyways, he pointed out it's estimated that every meter of air in the boundary between the UK and Norway translates to about $2 million of natural gas, or can translate to that much money. So when we're talking about a specific person in a room, when we're talking about an area that size, it actually it can be, it can be pricey. And I was kind of surprised that they kind of had this really general precision for something that's very expensive. So, and that's my last slide. Sorry that the keynote wasn't working. I guess I know this is one like the first presentation, so I guess I'll just be something for other presenters to be aware of. I'm probably going to Google it later and see if other people have had this issue with Keynote. But and that behind there is the Hubble Ultra Deep Field. And if you guys want, I can explain that. Let me just get a drink of water. So the astronomers decided, instead of focusing the Hubble telescope on like a planet or another star, they were going to kind of survey the whole nighttime sky and try to determine where is the darkest, most boring area in the sky. And they did that, and they decided, let's point the Hubble at it and let's go on the super highest zoom with the longest exposure we can. And let's look in this dark, dark area and see what we see. And this photo back here is actually the result. And as you can see, there's hundreds of galaxies and stars and all kinds of activity. And this is, it's kind of a mind-blowing image because it just shows you how big the universe is. So that's why it's one of my favorite photos. And I guess if you, as I understand, if you held your arm out, like arm's length, the area of the Hubble Ultra Deep Field is the size of your thumbnail. So imagine you're holding your arm out and looking at your thumbnail, and that's kind of the scale of what they focused on. So that's my talk. I hope you guys enjoyed it. I know it was a little discombobulated, but does anybody have any questions?
That was great, Patrick. Thank you. I think I'm reading, if you want to scroll to the no mic voice chat, I think
Okay.
I think Nuno had a question, and then I had a question.
Okay.
If it would be easier for you.
I like that no my drone image. Just 2 squares. Let's see.
The questions are just, we try to put like a queue, and so that way people can know their questions. Let me know if you can see them, or I can read them to you if that would be easier.
So you mentioned Google Maps, Apple Maps, and OSM. What do I think about Bing? Gosh, I hate to say it, I haven't thought much about Bing. Are you like, do you work with Bing, Megan?
I don't, but in the past, sometimes when I'm looking, and this is something I hate talking about, but when we update speed limits, sometimes we have like a certain software that we can like drive that the DOT provides, but sometimes it's just a lot of like ground truthing these speed limits. So I'll check, of course, Google and a couple other open sources, but sometimes I've found that Bing has really been helpful in some cases, not all. And so I just we talked about underdogs, and I don't know. I think Bing is definitely an underdog. Maybe it's an underdog for a reason. But I just wanted to get your thoughts.
Well, now that you mention it, the ground truthing part for OpenStreetMap, I believe Bing has made available aerial imagery and pretty good imagery too. So part of the OpenStreetMap workflow is using Bing aerial imagery if they have it. And So I think that's uh, hats off to Bing for providing that for free to the community. Um, let's see. Yeah. All right,
I
coordinates.
think Nuno asked a question right above
Oh,
mine.
so yeah, when OpenStreetMap uh, is being drawn over high resolution imagery, how do the errors in those images get translated to actual field error? And yeah, that's been like an ongoing dilemma with OpenStreetMap, because yeah, anybody can edit it. It's like Wikipedia. Um, I believe in JASM, there's a way you can actually shift the imagery. You can just use your arrow keys and kind of move the imagery. Um, and because yeah, that does come up, I think, pretty frequently whenever you do OpenStreetMap. Uh, when you're kind of tracing buildings. Um, I'm thinking even like as a surveyor, like I was doing some drone imagery. I had to get, or not drone imagery, but I was doing some geolocation stuff based on a drone point cloud, and that wasn't lining up. And it's more for reference. But yeah, with OpenStreetMap, I think that's going to be an ongoing issue. Is you're never going to get that survey grade accuracy. Um, I think there's always going to be a few feet of play between the like building corners and streets and the actual GPS coordinates, and I think that's just something everybody's going to have to accept. Um, yeah. Okay. What's the McDonald's burning down? How to burn a lot of calories. Do I think that? Do you think there will be a platform in the near future for near real-time updated mapping, uh, interactive like Google? Um, I think with AI and Internet of Things, I think there might be a lot more real-time data. Um, I think about that. There's that movie Prometheus, and I don't know if you guys have seen it, but there's a part where they're kind of there's a really kind of fun GIS part almost where they're doing they send these drones into this mountain, and there's all these tunnels, and the drones are flying around the tunnels like really fast, and you can see them mapping it. And I think we might someday have a world like that where there's these drones that are flying around and mapping all the time.
Yes, I just asked that question because I was thinking of all the small satellites that are out there. They're just every day, there's these private companies just launching tons of small sats. And just wondering if soon we'll be able to see the world as it's happening.
Yeah, or if it was like you could just click on a link and look at the satellite flying overhead right now and see like cars driving and people walking around. That would be interesting. I think there might be some privacy concerns, but the way technology is going, who knows? Um, and okay, yeah, I didn't know about Planet Lab, but yeah, that I could see it being useful to have daily imagery. I could see it being worth paying for it for some industries.
I think, Patrick, there was a question. It just wasn't marked. It was asking about what do you think about MapQuest?
MapQuest.
It's kind of up above, right above the McDonald's meme. It might have gotten lost. If you just want to scroll up just a bit.
Okay. MapQuest. Yeah, it's funny that mention that because here in Denver is where MapQuest. I think it's they've gone through some changes, but I remember going to meetups a few years ago, and there'd always be a couple MapQuest people, um, and it'd be kind of interesting talking to them because uh, they they were one of the biggest platforms, and now they're uh, now like it's really kind of my grandma uses them kind of thing, uh, but I have not checked. That'd be a good another slide to add to this to see kind of how MapQuest has what their precision is like. I remember using MapQuest a few months ago just for fun, and I thought the interface and the color scheme and the kind of the style was actually pretty decent. I remember it was kind of like a black and white style. Um, but yeah, I didn't go back. It's hard when you have Google in your pocket and Google's connected to everything. Does that kind of answer your question? Um,
Yeah, it does, I guess.
okay.
I'll be honest, I just got off work, so I sort of missed most of the presentation. But I was just curious, since we're talking about comparing the different mapping services, and it just occurred to me, everyone's using Google Maps for everything these days, um, and yeah, I think I did end up using, like a few years back, I started using MapQuest again because they had like gas station prices on it.
Yeah, sometimes that's how you got to differentiate yourself. Um, what kind of work do you do? Are you in the GIS community industry?
I use GIS as a grad student for some environmental science stuff, but not actually like working in the GIS industry at the moment. So I'm just like an end user currently. I've worked with stuff like ArcGIS and whatnot, but in terms of actually using like Google Maps or whatever, I'm just an end user.
hmm hmm Yeah, we're certainly lucky to have all these mapping applications. Does anybody else have any interesting stories about working with coordinates or anything like that?
I am driving. I don't know if anybody can hear me.
hmm
Um,
Yep.
yeah, I had to program the Vincenti conversion that you were talking about. I had to
Oh, nice.
program that in an Excel, yeah, in VBA in an Excel sheet. And that was one of the most nightmarish projects I have ever had in my life. Just miserable.
If you don't mind me asking, like, what application was that for to get that like level of accuracy?
Mostly the professor sadism.
Mm.
It was really just a teaching opportunity to try and get us to understand what the conversion looked like, the iterative process to improve the accuracy, but there was no application beyond that. It was make it so we could understand it.
Yeah, I wonder with Google Earth, I wonder if anybody's ever looked under the source code and seen how Google Earth does it, because I use that distance measuring tool in Google Earth all the time, and uh, yeah, I know they're kind of they're kind of a black box, but I wonder if anybody's ever seen that data. Oh, and we have a math question. uh, is it? Well, I'm thinking it must be a polar bear because is that the pole? White?
Do do not let this question fool you, because it definitely got me when he asked me. So please just ignore that comment. Um, Does anyone have any more questions for Patrick? I'm sure he'd be happy to answer them. If would it be okay if they message you, Patrick, and if they were to send you a direct message, would that be okay if they had any further questions, or if they were to post them in the server and kind of ping you? Would that be all right?
Yeah, probably the easiest way to reach me is my Twitter at map porn tweet. So
Oh,
that's like the only.
I meant to say,